Hello everyone, and welcome to Biopedia. This week we're back to looking at the impacts of anthropogenic climate change. We know that summer temperatures in 2023 were very warm. However, we're going to be talking about a 2024 study today which puts this into context across deep time. So what does this mean exactly? Well, the study looked at the 2023 temperatures compared to centuries past. This was done by obtaining monthly temperature data from something called Berkeley Earth to create average June to August temperatures in the area between 30 and 90 degrees of latitude. This Berkeley dataset goes back to 1850 in terms of its worldwide data, although some terrestrial areas do have data going back all the way to 1750. So that's given us data back to 1850. However, this wasn't all the study used. This dataset was then expanded backwards using data from 9 tree ring datasets. All in all, the final dataset ended up encompassing 2,000 years, all the way back to the first year of the Common Era. In other words, although we're skipping over some methodology here, an estimate was made of the July to August temperature all the way back to the start of the Common Era. The difference between observed temperatures in the period between 1850 and 1900 and the temperatures predicted by backwards modelling was included in the 2023 temperature to account for a warm bias in the early observed temperatures. So basically, what this refers to is that there is a difference between the actual observed data obtained from Berkeley Earth between 1850 and 1900 and temperatures which would be predicted by modelling. Now, the years before we get the Berkeley data kicking in are referred to as pre-instrumental years in the paper. Of these, the warmest on record was 248 CE, while the coldest was 565. Between these 2 years, there were 3.93 degrees Celsius of difference. Now, let's get to the main result of the paper. 2023 was, in fact, the warmest year in the non-tropical summer in the Northern Hemisphere in over 2,000 years. In fact, the 2023 temperatures were 0.5 degrees Celsius higher than the 95% confidence interval for natural climate variability. Now, let's back up and give a bit of a statistics definition at this point. A 95% confidence interval refers to the data range you are 95% confident contains the real mean of a given dataset. In other words, when applying this knowledge to this study, even if we're considering the range of data for which we are 95% certain would contain the mean temperature considering natural climate variability, the observed 2023 temperatures would still be half a degree Celsius above this. Other warm years listed in the study included 282 CE, 986 and 1081, while cold years include 627, 1601 and 1642. Let's see how these warm and cold years correspond to warm and cold periods that we know about across this range of about 2,000 years. First off, there's the Roman warm period. This lasted from the year 1 to 250 CE. Which would roughly fit with the warm year 282 CE and the warmest pre-instrumental year we mentioned, which was 248 CE. Moving forwards in time, we then get the late antique Little Ice Age between 536 and 660 CE. Again, this fits the cold years of 536 and 627. I believe we discussed the late antique Little Ice Age at least a little bit when discussing the first plague in episode 75. After this, we then get the medieval warm period or climate anomaly. Different sources that I've accessed have disagreed on the duration for this, but it's placed around the turn of the first millennium. The fact that this warm period is placed around this time fits with the warm year of 1061 CE. Finally, there's the Little Ice Age. Again, sources I've accessed have disagreed on when exactly this took place, but I'm going to say somewhere in the 1400s to 1700s, which seems to encapsulate most if not all of them. Again, this fits with the data mentioned in this study. Specifically, this would encompass the cold years of 1601 and 1642. Now, the other events that we mentioned here, the late Antique Little Ice Age, the Roman Warm Period, and so on, were caused by natural phenomena. However, the warming responsible for the abnormally high temperatures in 2023 is clearly anthropogenic. In fact, the authors of this 2024 paper end their discussion by calling for action towards net zero to be taken immediately. Therefore, this episode once again highlights the impact that humans are having on the planet around them. That thought brings us to the end of today's episode. As always, thank you all for listening. Feel free to get in touch at the show's email address for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.